there folks, Mr. G here with another educational video. Today we're starting our new unit. So before we dive into it, it's probably important to talk about what algebra actually means. Now the idea of algebra is, how can we do a math problem if we don't know the number that we're supposed to be working with? So for example, what if we wanted to know what number times 2 plus 8 gives us 12? This idea of what number, this is the whole core of what algebra means. Anytime we don't know what the number should be, but we know some other stuff about it, that's when we can use algebra. And we can represent this number like we have been so far with something like a question mark. So what this really tells us is some number times 2 plus another 8 gives us, is equal to 12. When we have this unknown number, what we use to represent this is called a variable. And this variable is kind of just like a placeholder, like this question mark, for the number that we're trying to figure out. And oftentimes, instead of numbers for our variables, we use letters. So we could use letters like A, B, or C, or X, or Y, or Z, or any other letters that you like. And this is the core of algebra, is using variables to represent numbers that we don't know. So if we were to rewrite this using variables, we would write this as, say, x times 2 plus 8 equals 12. Or another way we can write x times 2 is 2x plus 8 equals 12. Any time that we have an equal sign with our variables here, this is called an algebraic equation. The reason why we call it an equation, if you notice the start of equation has the same start as the word equal, what that tells us is that our variables, our algebra, has an equal sign in it. So we've got some variables and an equal sign. That's what makes an algebraic equation. If we just have the first part here, the 2x plus 8, but with no equal sign, we have a different name for this. We call this an algebraic expression. The idea here is that we have variables, but no equal sign. Now it might seem sort of silly to come up with two different names, one for the stuff with equal signs, one without, but it turns out that these things are used really differently, and it's important that we talk about them differently as well. And we'll see more examples of that as we go through this unit. One of the most useful ways that we can use algebra is by turning a word statement or a sentence into an algebraic expression. This helps us link word problems or situations like the one we started off with, what number times 2 plus 8 is 12, and links that to the math, to our algebraic expressions. This is the first step in any sort of problem solving and also gives us some motivation about why we might care about algebra in the first place. So if we had a sentence or a situation where we were trying to figure out what is a number minus 5, how would we represent that using variables and numbers? The way that we would do this, a number minus 5, anytime you see the words a number, this is a variable. And we can give any name we want to this. Let's say we go with y this time. So this says y minus 5. What if we change up the order? Now 5 minus a number. Again, this number, this unknown number, that's going to be our variable. But now we're doing 5 minus this mystery number, which means our algebraic expression is going to look very similar to this, but reversed. So now it's going to be 5 minus our mystery number, our variable. Let's say we give it a different letter. Let's give it a letter like A. That's how we would turn this word statement into an algebraic expression. The product of 2 and a number, this word here, product, this means multiply. So if you see the word product, that means multiply. And what this tells us is that we're multiplying 2 and a number. Or in other words, a variable. So to write this out using an algebraic expression, we would do 2 times any variable you like. Let's do x this time. So 2 times x, or that's also the same as 2x written like this. Those mean the same thing. If you see the word quotient, this means divide. So if we have the quotient of a number in 6, again, this number is our variable. And when we're talking about quotients, the first one that we list is what goes on top in our numerator, and the second one we list goes on the bottom in our denominator. So the way we could write this out would be something like our variable, like b, let's say, divided by 6. Or you could write it out b divided by 6. Maybe we should choose a different letter than b because it looks very similar to 6. Let's do a different letter like c instead. That looks much better. What about the quotient of 6 and a number? Now we've swapped the order, so we're going to swap which one goes on top. This would be 6 over a variable, let's say like k. Or in other words, 6 divided by k. Something like 5 more than a number. When we're talking about more than a number, that's like adding. So this would be something like our number, our mystery number, let's say p. And we want 5 more than that, so that would be like p plus 5. So these are some of the examples where we might start off with a word statement and turn it into an algebraic expression. What if we wanted to go backwards? What if we started with something like x plus 2 and we wanted to imagine what sort of word statement we could use to describe this situation, some mystery number plus 2. We could write a number plus 2. That's one way we could describe this algebraic expression. But it's not the only way. Like we saw above, another way for talking about adding is saying something's more. So we could also say 2 more than a number. Another word we can use for adding is the word sum. So we could say the sum of a number and 2. The key thing to recognize here is that when we start with an algebraic expression, there's a lot of different word statements that we can get from this. Going in the other direction, where we have a single word statement, there's only one algebraic expression that should match this. But when we start with an algebraic expression, there's a lot of different ways we can describe it. If we had something like y minus 5, that's the same as a number minus 5, 5 less than a number decreased by 5. There's even more possibilities, right? There's lots of different ways we could write this. These are probably some of the more common ones. Here are some more examples for dividing and multiplying. The quotient of 4 and a number, 4 divided by a number, those both mean this. 3 times a, 3 times a number, the product of 3 and a number, triple a number, triple that also means times 3. So there's a lot of different ways that we can take algebraic expressions and turn them into words. The other thing I'd like to talk about is how we might evaluate an algebraic expression. So if we have an expression like this, 3x plus y, and we're told what our mystery numbers are, what our variables are, in this case x is equal to 7 and y is equal to 1, and we want to evaluate what does this algebraic expression eventually equal. So when we use these as our variables, these values, what does this equal? The key here, when you're doing these types of questions, is to remember BEDMAS. So what we're going to do is we're going to substitute in these numbers in for x and y. And anytime you substitute it in, I really encourage you to put brackets around these numbers. Sometimes this won't make a big difference, but sometimes it will. And you'll never get it wrong because you put brackets around these numbers when you put them in. But you might get it wrong if you forget to do it. So my suggestion anytime you make a substitution is that you put brackets around the numbers that you're plugging in. So for this one here, we would have 3, and then for our x, we would have a bracket, we put our 7 in, and then the same thing where we put our y, we'll put this 1 right here. From here, once we have our numbers in, this is just like a BEDMAS problem that we started the year with. Notice this, when we've got a number next to a bracket, that's the same as multiplying. If we're thinking between multiplying and adding which one comes first, we do the multiplying first. 3 times 7, that gives us 21. And then the brackets around this 1 don't really change anything. They don't do anything, so we can just get rid of them. And then we can add these two together and get our final answer of 22. How about something a little bit harder? We've got x squared plus 6y divided by z, and we're told the values for each of our variables. Just like before, I always like putting these brackets around here to remind me that when I plug these in, I should be plugging them in with brackets. The other thing I want to point out, when I draw my z's, I always draw a line through the middle like this, and that's because if you don't, the z looks an awful lot like a 2. At least mine does. So to avoid confusing myself about which one's a 2, which one's a z, I put a little line through it so that I can see which one's supposed to be a z and which one's supposed to be a 2. So here x is negative 4. When we plug it in here, we put the negative 4 in brackets, and all of this is getting squared. Plus 6 times our variable y here, which we said was a 2. And then we're dividing by our variable z, which we said was a negative 3. Now if we look back at BEDMAS, right? Brackets, well, we can't simplify anything inside of our brackets, but exponents, in this case, we actually do have an exponent. We have negative 4 squared. Negative 4 squared, keep in mind that when we square a number, that's like the number times itself. Negative 4 times negative 4 would give us positive 16. So this thing right here would be equal to positive 16, and then we just leave everything else the same. There's exponents done. The next thing we would do is dividing and multiplying, and we start from the left. Remember, there's a multiplying sign when we have a number in front of a bracket. So this would be the same as 16 plus 6 times 2, which is 12, divided by negative 3. Now you might be tempted, oh, I can add these two things together. Isn't that great? But remember, for BEDMAS, we would do division next. So we would do 12 divided by negative 3. 12 divided by 3 is 4, but a positive divided by a negative gives us a negative. 16 minus 4 gives us our final answer of 12. Last example here, negative 4 bracket 2x minus y, where x is negative 3 and y is negative 2. Again, when you're doing these substitutions, put brackets around each of these numbers. It'll make it really clear what you need to do when you plug it in here. So we leave the 4 and the 2 here all the same, but this negative 3 goes in brackets, minus our negative 2, also in brackets. And now we can see what we need to do here, right? We start inside of our brackets here, because brackets come first before anything else. And we notice that inside our brackets we have a multiplying and a subtracting. We would do the multiplying first. 2 times negative 3 would give us negative 6 minus negative 2. We're still not done in these brackets. We've got minus a negative number, minus a negative. That's the same as a plus. So this would be the same as negative 6 plus 2. Negative 6 plus 2 gives us negative 4 inside of our brackets and a negative 4 on the outside. Remember, two sets of number outside a set of brackets here. This is the same as multiplying. Negative times a negative gives us a positive. 4 times 4 gives us 16. Alrighty folks, let's check your understanding. 4 questions up here. Pause the video, grab a piece of paper, try them out for yourself, and we'll go over the answers in just a moment. All done? All right, let's go over the answers. For our first one here, we're looking for algebraic expressions, and if you remember, the key with an algebraic expression is that it had no equals sign. That was the key. So looking at these here, we can immediately cross off all the ones that have an equal sign. And it would be the remainder here, these 3, that would all be algebraic expressions. These 2 here would be algebraic equations. That's the answer to the first one. For this one here, we're trying to write an algebraic expression for this sentence, the quotient of 6 and a number. Now, if you remember, quotient here, this means divide. And the order that it's listed tells us which one's on top, then which one's on the bottom. So as a algebraic expression, this would be 6 divided by some variable, say x. So 6 over x would be the algebraic expression for this. Doing this in reverse, we want to write 2 different sentences for this right here. Anytime you see subtraction, you could go up to this table that we saw up here. We look for some of these key words: minus, less, decreased. Let's see if we can use all 3. So you only had to come up with 2, but I'll use all 3 here. So we could use minus, 3 minus a number. We could use decreased, 3 decreased by a number. The order is important here. Whichever one comes first tells us which one's coming first here. 3 is being decreased by some number. The last one's a little bit tricky because now, if we looked back at the table, 5 less than a number was when we subtracted by 5. So we'd have to swap the order and it would be a number less than 3. You could also write 3 subtracted by a number. And again, these are just 4 possible answers. There's lots of other different ones that you could do, but I think these 4 are probably the most common. For our last one here, we're substituting these things and evaluating. And again, it's super important. When you substitute these in, substitute them with brackets. You're less likely to make a mistake that way. And if you do, you should end up with something like this. Now, we've got a lot of stuff going on here, but again, we would start off with bedmass. Nothing inside of our brackets we can simplify, no exponents, but we want to start with dividing and multiplying. And actually, we've got a couple different places where this is happening. We've got 2 multiplications and a division, but we start on the left here. So we would start by 3 times negative 10, which gives us negative 30. Next, we would do this. Negative divided by negative gives us a positive. 30 divided by 2 gives us 15. This multiplication here, we've got negative 4 times negative 1. We've got a negative and a negative. That would give us a positive when we multiply. So this is going to be 15 plus 4. 15 plus 4, that would give us an answer of 19. That's the end of our video here. Thanks for tuning in. Make sure you complete all of the homework on Teams as well as any other activities, and I'll see you all in the next video.